So when we're looking at our factors, the first thing that we're going to do is we are going to go 1 0 at a time. So a 0 at 4, we change the sign, so it's x minus 4 since it was a positive 4. The reason we do that because it's at 0 at 4. If I put 4 in for x here, this does in fact equal 0. And we put the multiplicity of 2. That means that the 2 goes as our exponent. We go to the next one, 0 at negative 3. Again, we change the sign. It was negative, now it's going to be positive, plus 3. And the multiplicity of 7. And again, the reason we do that, we change the sign because negative 3 plus 3 does equal 0. And then the last one, I have a 0 at 12. And I change the sign, and it has a multiplicity of 6. So this is the factored form that would have those 3 zeros and would have those particular multiplicities. In order to figure out the degree, I take these 3 values, those multiplicities, and I just add them up. So 2 plus 7 plus 6. 2 and 7 is 9. 9 and 6 is 15. So if I multiplied this fully out, I would see the exponent of 15 in the final product, the x to the 15th, and then the other terms. The second part says to write a second polynomial in factored form that fits the description above but has a different degree. Well, all of this needs to stay in the problem because it has to have the same zeros and the same multiplicities. I'm just going to keep this part the same. But it has to have a different degree. And this is the big idea. How can we add a factor that does not add a 0, but adds to the degree? And that's where we're going to be adding this x squared. And it could be x squared plus any positive number that you like. I generally just write 1 just because it's a low number. But you could write plus 102. You could write plus 75, plus 7,632,000, whatever number you want, so long as it's positive. Because if I tried to solve it, and I just actually did this x squared plus 1, set it equal to 0, I'm going to end up with a negative answer. And we know that x squared cannot be negative. There is no number that times itself gets you -1. 1 times 1 is a positive 1. -1 times -1 is a positive 1. This just does not exist. This is actually an imaginary number, sorry. An imaginary number. For purposes of our degree, though, we continue to add these multiplicities, but we also just add the 2 as our exponent. So this one would have a multiplicity or a degree of 17.